Hello and welcome back. Today we're talking about ensemble models, and specifically we're covering a technique called stacking. So let's say you have a problem and you've created a linear regression model to solve that problem. You've also created an XGBoost model to solve the same problem, and you've created a neural network to solve the same problem. And you're pretty happy with each one of these models. Each one has its own pros and cons, but on overall, you're pretty happy with each one. And you don't want to just select one and go with that approach. You want to combine the results of the three. How would you do that? Well, this is where ensembling comes into play. And a simple way to do that would be to take a simple average of the predictions of each one of these models. A more involved way to do this would be to take a weighted average of these models. And here we have weights, alpha 1, alpha 2, and alpha 3. And it's up to you to decide what these weights are. As the machine learning engineer, you would need to see which of these models is better equipped for the problem at hand and things like that. Make some judgment calls and select these weights. Now, an even more advanced way of approaching this would be to use a technique called stacking, where rather than a simple or weighted average, we use a meta model. So these three models are called the base models. They create predictions, and then the meta model uses those predictions, is trained on those predictions, and it creates its own output, which will be the final output. So that's what stacking is all about. We have the base models, and then we have a meta model. This is a high-level overview. Now we're going to dive into all of this in a bit more depth. Before we do, I wanted to say that in this example, as you can see, we're dealing with a regression problem because we've got regression here, XGBoost for regression, the neural network for regression, and we've got the meta model, which is also a regression model. In this case, it's simple linear regression. Of course, the same principles apply to classification. You would just have classification models here and here. And one other thing is that these models, there could be any number of them, and they can be any kinds of models. We just took these for argument's sake. And here, same thing. For the meta model, we're using a linear regression, but it could be any model that you like. So let's dive into this. Let's say you have this data where you have 4 features and 1 dependent variable. Now, what you're going to do is you're going to split into several folds. In this case, we're doing 4 folds. And you're going to train model 1 on this data. Effectively, we're applying k-fold cross-validation to model 1. And k-fold cross-validation is something we discussed in machine learning level 2. That's our previous course. And you can find more details on that there. In case you need a quick refresher, this is how it works. Basically, what we do is we take one of the folds. In this case, we're taking this 4th fold. We're excluding it. We're training the model, in this case model 1. We're training model 1 on the first 3 folds. So we're training model 1 over here. And then we're applying this trained model to this data. So we're applying it to this data and we get this result. So that's our result for model 1 applied on trained on the first 3 folds and applied to fold number 4. And we'll continue doing this. For example, for fold number 3, we would exclude fold number 3 from the training. We would train the data on fold 1, 2, and 4. We'd combine these other folds. We'd train the model on that, apply it then to fold number 3, and get these values over here. And by the way, this is just a small data set. Of course, there could be many, many more rows in our data, and you can choose any number of folds that you want to do apply in this technique. So as a result, we would get these values. So these are our predictions with model 1 using k-fold cross-validation. Now, we would repeat the same process for model number 2, which in our case is XGBoost, and for model number 3, which is a neural network in our case. And then what we would get is we would get a column of predicted values for model 1, a column of predicted values for XGBoost, a column of predicted values for the neural network. And to all of this, so these are actual results. So we could go, if we wanted to use just one model, let's say we just wanted to use a linear model, we already have this is the trained model and this is its predictions. But because we want to use an ensemble, what we're going to do is we're going to add over here our dependent variable one again, right? So we've already used our dependent variable previously over here during this k-fold cross-validation process in this training. But now we're going to add the column, or we're going to include the column of the dependent variable one more time over here. And we're going to use this data now with these predictions. We're going to use that to train the meta model, as we discussed at the start. So that will give us a trained meta model. You might be wondering at this stage, what about the test data for the meta model? Where are we going to get that? Well, it's a good question. Let's have a look. So this is our train data. So far, we've only been working with the training data. We still have the test data untouched. So from the training data, we've been able to get these 3 columns and get this. Then we've added the dependent variable again, and then we use all of this for training the meta model. Now, if we look at the test data, which we haven't touched so far, we've got, again, 4 features and the dependent variable. What we're going to do is we're going to train each one of the models, M1, M2, and M3, on this full data. So no more k-fold cross-validation. So we take the model M1, we train it on all of this data, and then we apply it to this test data, and it'll give us this one column. Then we do the same thing for M2. We train model 2 on all of this data, and we apply it to this test data, and then we get this second column. And then we do the same thing for model 3. We train it on all of this data, we apply it to the test data, and we get this third column with the predictions of model 3 on the test data. And then again, we copy paste the dependent variable. So now this will be our test data. So this is our training data for the meta model, and this is our test data for the meta model. And so from here, what we would do is we just train the meta model on this, and we would test it on this like we do with any normal modeling process. So here are our 3 models. As a recap, what we do is we combine their results to create a meta model. This process is called stacking, and the meta model will give us a prediction. So whenever you have a new observation in your data set, well, a new observation that you need to make a prediction for, you would feed the features of that data set into the first model, get a prediction. A second model, get a prediction. A third model, get a prediction. So then you would take the predictions of these 3 models for that new observation, and they're the outputs of these 3 models. You would put, they would become inputs into the meta model, and the meta model would make a prediction, an overall prediction, and that's the final result that you would use for that observation. Now make sure to check out these videos on the right or the full course in the description to continue your learning, and I look forward to seeing you there.